So welcome, I'm going to take a look at Greenberg motors, and this is from chapter 3 from your textbook, and this is 3-11, and again you can look below and you'll see the link to the website for the textbook, and then click on chapter 3, and then download the files, the downloadable files, and this is 3-11. So what I'm going to do is I'm going to take this and I'm going to copy it. So I'm just going to click on my right button here, and it goes to move or copy, and I will create a copy. Okay, and I'll just move it to the end. Okay, so I got my copy right here. So here's the real thing, and here's the copy. You don't really don't notice a difference. So what I'm going to do is I'm going to erase all the number of units. Okay, so let's take a look. Now, these are two different types of motors, and I guess they're motors that are used in appliances. So we've got the motor A, and we've got the motor B. All right, and again, this is multi-period production. So the cost of producing is $10, and you'll see over here. All right, so from January to February, it is $10, and then from March to April, it's $11. That's a 10% increase. So you would just take $10 and multiply by 1.1, which would give you 11, which is a 10% increase. Same thing for here, 10% increase in the unit cost of making the B motor, right? And that would be $6 times 1.1, which would get you $6.60. All right, so those are the two costs in terms of production per unit. All right, so this is production right here, and this is A, so this is $10. All right, and production again for here is $10. And now we're into March, and that's $11, and then April, $11. All right, now production, this is for B. So here we are at B, and it was $6, and then production again, $6. And then production went up to $6.60 and $6.60. So that's a 10% increase that they mentioned in the problem. Now for inventory, there's some associated costs for inventory. We can take a look here. All right, and this is the holding cost for inventory. So slightly more for Model A motor, and for Model B motor, it's 13 cents. So we'll put that in. Okay, and that's on a sort of per unit. Okay, so we got 18 cents here. All right, underneath is inventory again, 18 cents. All right, 18 cents. And finally, 18 cents. All right, and the other one is 13 cents for the carrying, the holding of inventory. So we can just point 1, 3. All right, press enter. And then we could just do the Control C and then just copy. Okay, now we got the cost for that. Now this is minimizing costs, so we would use the sum product here. So we just go equals and then sum product. Okay, so we got the first array are the costs going across, and then we got the second array here. And we can highlight that. All right, then I'll hit F4. And that makes it a reference. That's an absolute reference. All right, so that would be fixed to it. Okay, so in terms of what we got for production and for inventory for January balance, so let's take a look at our formulation. Okay, so we figured out the minimizing total cost. So we got cost of production, that's what we just did. Cost of carrying inventory, and again, it's $10 for the first 2 months, $11 for the second 2 months. And for motor B, it's $6 for the first 2 months. And then again, another 10% increase and $6.60. And again, the inventory costs were 18 cents for each month for motor A. And the cost of carrying inventory is 13 cents for motor B. Okay, so here's our formula in terms of balance of equations. So what we got here, right here too, is what we have to sell. And what we have to sell comes from production or what we already have in our inventory. And that's available to sell. And then minus current period sales, and anything left over is our inventory at the end of the current period. Now the sales are all put down here. So So the customer says we need 800 in January. So, ship us 800 in January, 700 in February, 1,000 in March, and 1,100 in April. And for the B motor, it's going to be 1,000 for January, February, 1,200, and then for March and April, 1,400 each. All right, so that's already the customer saying we need these to be shipped to us at that time. All right, so that can be our current period sales, those numbers that were given here. Now take a look here, and this is 0 because what they've said before is these are new motors, and therefore and they're starting January with new motors. It's a redesign, so and the old motors just won't do it, so they're starting with 0 inventory. That's what that means for 0. So both motor A and motor B that are going to be the motors and appliances, they have a starting of 0. Right, and again, their customer says, hey, we'll take 800 in January of motor A, we'll take 1,000 of motor B in January as well. Now, when we're putting this into Excel in terms of what we would like to have, which would fit together quite nicely, is we would like to have all of the decision variables on the left-hand side, okay, and all of the parameters on the right-hand side. So we would like to have 800 on the other side of the equals sign. Okay, and again, this equals means that the customer ordered 800, and we need to, whether by production or by inventory, fill that exactly, right? Because they've given that to us ahead of time. All right, so we can get 800 on the other side by adding 800 to both sides of the equation. And we can get the inventory for January, we can get that on the other side by subtracting this from both sides. And that's how we get this here. Okay, so for production, we're going to have 1. And here we're going to have -1, which sounds a little strange, but again, the reason why it's -1 is this is going to be on the other side of the equal sign. And again, how do we get rid of this on this side? We subtract this figure from both sides. And then this will cancel out, and it'll reappear here as a negative. But remember, in front of each of these decision variables is a 1. So this will be a 1, and the other one will have a -1. And this will become positive because we added 800 to both sides. All right, so over here on the right-hand side, this would be 800. And this would be equals. All right, so we want to have that. And again, in terms of sum product, we can put that in there. So we can go equals and then sum product. And then we can have our first array, which is right here, going all the way across. And again, we go all the way across because then we can copy this formula right down. And then we can have there we are. And then do the number of units that we'll make. And again, we'll make this a fixed reference. All right, we can copy that formula all the way down. Okay, and again, we can just test it. There we go, it's hitting the right stuff. Okay, so that's for the motor. And notice that this is, if we go across row 8, this is just for motor A. All right, now we've got motor B for January. Motor B for January, so here's motor B on this side, and for January, it would be here. All right, so we would have the same thing. It would be a 1, and then the inventory would be -1. And again, if you're not understanding why it would be -1, just take a look at the notes for session 6. It'll give you more of a background. It's essentially algebraic manipulation. Bringing something over onto the other side is going to make it, in this case, negative. Now, it's not 800 for, if we take a look here, okay, so it's going to be 1,000, right? And again, this 1,000 would go onto the other side of the equal sign, right? We get rid of this 1,000 by adding 1,000 to both sides of the equation. And that's for the amount of motors in January. Okay, for motor B. Okay, and these are all going to be equal, so we can bring those down. So this would be 1,000. All right, we started in January, and we didn't have anything from December, something from December being brought over because it's a new model year and our customer won't accept any sort of previous models.